Up to now, we talked rather generally about parallel computing. Now I want to talk a bit more about query parallelism. And there's going to be two sorts of query parallelism. The first we'll call inter-query parallelism, where we get parallelism across multiple queries. So in the picture on the right, you can imagine lots of clients connecting to a database, each one issuing an SQL query. And we want those SQL queries to run in parallel. So each query is going to run maybe on a separate processor. So it's a single thread with no parallelism per query. The parallelism is across queries. So really what the database needs to manage here is just the scheduling of queries to threads and the issue of parallel-aware concurrency control if multiple of these queries are updating and reading the same data. That's a topic we'll cover later in the semester, concurrency control. But in the meantime, if they were all read-only queries, you can imagine that they could just run independently. They share whatever memory and disk bandwidth is around, but they run independently. Now, inter-query parallelism is in some sense therefore relatively easy. And we're going to focus more on intra-query parallelism in the next slide. Before we do that, a quick note on Latin prefixes that we use in English. Inter means between or across, like interplanetary travel. It takes a long time. Intra means within, as in the political party suffered from intra-party rivalries. Okay, so this is inter-query parallelism. Let's look at intra-query parallelism. So intra-query parallelism comes in different flavors itself. One is inter-operator, but intra-query. So within a single query, intra-query, but across multiple operators, inter-operator, we have parallelism. Pipeline parallelism is an example of inter-operator, intra-query parallelism, right? Because the green, the blue, and the white operators are all running in parallel, finishing the work of one query, 3 records simultaneously at a time. Another kind of inter-operator parallelism comes when you have a logical plan that looks like this, where there's things on the right-hand and left-hand side of an operator that are themselves computations. So you can think of this as sort of a bushy tree. It's a tree that's not skinny, it's kind of bushy. And so this is sometimes called bushy or tree parallelism. And if you put a materialization operator on the top of these two joins, materialization means just store the output to disk and then allow it to be read back in by the parent. Then the blue subtree, the join of R and S and the materialization operator, can run on one machine. The white subtree, T and U and its join and materialization, can run on a second, completely in parallel. And then when they're both done and they finish in parallel, then the gray operator can read from the outputs of each of them that have been materialized on disk. Okay, so bushy tree parallelism is also inter-operator, but it's not in a pipeline. It's across these two subtrees. And again, you can combine these. So you can have pipelines on either side as well as bushy parallelism. Now, intra-operator is also an option. So this intra-query intra-operator. So within a single operator can we get parallelism. So given a query plan like the one on the left, the join of R and S, we can get partition parallelism so that single join operator actually runs on multiple nodes. So let's summarize what we've seen so far at a high level. We have inter-query parallelism, where multiple SQL queries run in parallel. And then we have various kinds of intra-query parallelism. We have inter-operator parallelism, including pipeline and bushy parallelism. And we have intra-operator parallelism, in which a single operator is parallelized, typically via partitioning. Okay, and we're going to go into that in more depth now.